Hey everyone, I'm Anish and again welcome back to PrepFusion. So today we'll be starting the lecture 2 of control systems, right? So in the lecture 1 we learned about the mapping theorem. We learned what is the definition of mapping theorem, right? And why is it used, right? And what does mapping theorem does? Basically, what does mapping theorem do? It basically maps some variable into some other function, right? Like it is mapping this contour, right? It is mapping this contour to this f of s, right? So whatever points lie in this contour, I am mapping this to some other contour like this one, right? So basically which is related like the function of f of s, right? The relation is f of s, okay, s by s plus 2, and I'm mapping this to other contour. That is what basically mapping is. Now how will it help us in finding the stability of control systems? All these things we'll learn slowly, right? So I told you in the last lecture to notice something, to notice about the like when will my this mapped contour will contain the origin, right? Surface will contain the origin. When will it not contain the origin? Why is it sometimes rotating in the anti-clockwise direction? Why is it sometimes rotating in the clockwise direction, right? So I told you to like figure out those things. So here, right, I will like tell you the conclusion. Basically, first thing is, what do we mean by poles and zero? Let me quickly revise, right? So poles, what does poles of f of s mean, right? Poles of f of s means the value of s at which what the denominator of my f of s becomes 0. Obviously f of s goes to infinity, right? That we know. So this means that f of s at s is equals to sp equals to simply infinity, right? Tends to infinity. Okay. Now what does zeros of f of s mean? Basically at that value of s, right? Obviously my f of s goes to 0. Okay. So it goes to 0. The value of f of s is 0. Now can you like find out the pole zeros in the three cases, right? A, B, C. Like if we go back, A, B and C, right? A, B and C. So what are the three cases? Like in the first case, what was the pole and 0? So here, right, this was the case 1 basically. This one was the case 1. So in the case 1 I had a 0 at s equals to -1 and a pole at s equals to -3. So 0 at s equals to -1 and a pole at s equals to -3. Pole at -3, 0 at -1. Okay. Now what about my other case, right? So the part B. So at the part B, basically, second question basically, I had a pole at s equals to 0 and 0 at s equals to -1. So even if there is some s in the denominator, you might think there is no pole. It is, right? It is hidden. Like s equal to 0 is the pole basically. So s equal to 0 is the pole and s equals to -1 is the 0 basically, right? So yeah, am I doing this correct? Let me just quickly check. Yeah, -1 is 0. Yeah, fine. So now let's go for the second one, right? Second one. So in the second one, what is like third one? What is it? S equals to 0. Like is a 0 of this f of s, and s equals to -2 is a pole basically. So s equal to 0 is a 0 basically, right? So 3. And s equals to -1 is a pole, right? Am I correct? Yeah, no, sorry, s equals to -2 is a correct pole. S equals to -2 is a pole. Okay, so now what conclusion can we get from this? So let me copy the contour, right? and draw the pole zero diagram. So I like okay, I have already drawn this all this, right? So in the first case, right, in the first case, what is happening? In the first case, basically, I am drawing the pole zero diagram with the contour, okay, to see that whether the poles and zeros are inside the contour or are outside the contour or lie on the contour itself. So here I have a pole 0, right, and like this was the first case, right? Pole is at -3, so it is lying outside the contour. This is at -3 outside the contour, and 0 is at -1, which is on the contour itself, right? So if it is on the contour, then what does this mean? This means, like I have, like I told you one thing, right? If a 0 is on the contour, then my this mapped function, right, this mapped function will also pass through the origin. Let's cross check that, right? Let's cross check that. In the first case, okay, in the first case it was on the contour, 0 was on the contour, then what happened? Yeah, it touched the origin, right? It will touch the origin. So origin, right, origin will touch it, right? So, and what is the other thing? The other thing is that I can see that the direction of my contour, right, my direction of the contour is in the anti-clockwise direction, which is same as the, like the map contour is in the anti-clockwise direction, which is same as the actual contour. What does this mean? This means there was a 0 there. So if 0 is present, right, it doesn't change the direction. If 0 is present inside or on the contour, it doesn't change the direction. So 0 doesn't change the direction, and like if 0 is on the contour itself, then my mapped contour will obviously touch the origin, but it will, like, origin will not lie inside the map contour, but it will touch the origin, right? So due to this 0, right, due to 0, my basically mapped contour, due to 0, contour touches the origin, right? Okay, my map contour touches the origin, and also like direction is same as the contour itself. The direction of the map contour is same as the contour itself. So as no pole is present inside, okay, that hint has been given out. No zero, like obviously only 0 doesn't change the direction. So direction of mapped contour is also same, right? Direction of map contour is also same. Okay, let us now go to the second example. Now before going to the second example, one thing I want to mention is that one mistake has been done, basically, like I noticed after doing it. Basically here, right, I did the Python plot here, like with the plotting Python function, but there has been a bit of mistake here. Like this plot won't be like this. There will be actually two contours which the Python wasn't able to comprehend, right? It wasn't able to plot it. That's where the mistake occurred. So there will be two plots, right? One will be basically clockwise and another one will be anti-clockwise, and that other one will obviously will cover the origin, basically will cover the origin, but here it didn't, right? So like I have to delete this one, right? Delete this one. I'll show you, like I can't exactly show you how the Python plot would look like, but I can show you in approximation how it will look like, right? So if my contour is like this, okay, if my contour is like this, then what I can do is that, like, let me draw the pole zero diagram. Okay, so I'm telling you the conclusion now itself, because like that mistake has been done by me. So here, right, I had a 0 here and pole inside the origin, basically. So pole is inside this contour. Now if pole lies inside the contour, like the total number of poles and zeros will decide the number of encirclements about origin. We'll come to that point, don't worry. Okay, so from here I can tell that the mistake has been done, and like whichever, if 0 is touching my contour, obviously I will get the contour, one of the contour will also touch the 0, right, of the mapped contour, and yeah, and if pole is touching, then one of the contour will go to infinity. We'll understand slowly. If you do more examples, we'll understand. Don't wait, right? So now I'm doing the mapped contour basically. Imaginary of f of s, right? And real of f of s. Real of f of s, right? So like from here what I can tell is there will be at least, like there will be two contours, right? One will touch the origin basically, like this one, right? One will touch the origin, and the direction of that contour will be this anti-clockwise, right? Same as the previous contour itself. Direction of the map contour will be same. Now I will have another contour. What will happen with that contour is the direction of the contour will be in the clockwise direction, and okay, my drawing is really bad. Direction of contour will be in the clockwise direction, and what will happen, and basically, right, basically it will cover the origin. Okay, it will cover the origin. So this will be my other contour, right? Let's say this is my other contour. Very bad drawing, rough drawing, right? And now the direction of this mapped contour will be in the clockwise direction. Okay, and like it will cover the origin, right? It will cover the origin. Okay, so yeah, this is this one. Now this is due to the s equals to 0 basically, the origin pole. Okay, and this is due to the sorry, this is the pole, and this is due to the 0 basically. Okay, so yeah, this is this one. So yeah, that was one mistake. So here also, like what I told you the conclusion itself, that there will be one encirclement about the origin and one will touch the 0. Okay, one will touch the 0 basically. So oh yeah, just be careful about that, right? Just be careful about this thing. So like let's go to the next one basically, but before that, like here what will happen, due to this pole, one contour will get one contour in the clockwise direction, right? Okay, and due to the 0 we'll get one contour in the, now as here, right, we only got one contour. Why? Because this pole was lying outside here. This pole was lying outside, that's why we only got one contour. Okay, so yeah, anti-clockwise direction. Okay, so yeah, this one. Now what about my C? Again, right, 0 is lying inside this contour, then what will happen, due to the 0 we'll get one mapped contour itself. This pole is lying outside, so we won't get any contour due to this one, and obviously the direction of rotation will be anti-clockwise itself, right, due to this 0. So direction, we'll get one contour anti-clockwise, whose direction is anti-clockwise. So there is no direction change. Okay, no direction change. Here we had direction change. Okay, let me write some different pen basically. let me color this one. And here also we have direction, no direction change, right? Okay, so all of this is this one. So this is the basically conclusion you can see from the plot itself. Here it is correct because I didn't have two contours, right? Then Python was able to do it, but for two contours it wasn't able to. That's my mistake basically. So here we can see it is like origin is covered, right, in this contour. So yeah, from here you can cross verify again. The direction of the contour is what, anti-clockwise. So like I have like written the points. Okay, you can understand from here. If zeros of the mapping function lie inside the contour, then direction of the mapped contour won't change. If only let's say zeros are lying. Okay, if any zero is lying, that zero due to the like zero whatever contour will get right in the mapped contour. If it lies inside the contour, direction of the mapped contour due to the zero won't change. Now if poles of the mapping function lie inside the contour, right, then direction of the mapped contour will change. Okay, the contour that we will get due to the pole, the direction will be opposite to that of the given contour. Okay, if origin will lie inside the mapped contour, right, I should say inside the mapped contour. In f of s plane, if either poles or zero lie but not all inside the previous contour. So from this we will understand, this will be cleared later slide side. All this also will be cleared with examples. We'll do examples and from there you will be able to understand. But before that, right, like I want to give you one example of we have been doing mapping itself from the polar plot itself. In polar plot, what we used to do, in polar plot we used to vary omega from 0 to infinity, right? So in polar plot, 0 to infinity, right, we used to vary omega between 0 to infinity. So that is what we used to do. So omega is going from here to here, and what we used to do, we used to plot the imaginary of the OL tip, right, and omega used to get varied, and we would have mapped the OL tip was the mapping function basically, and this was the plane, right, and this was the contour. Okay, not the overall contour because this is just the half contour, right, because it's not coming back, right, because omega is just varying from 0 to infinity. But in mapping function, what we should do is we vary from minus infinity to infinity to get a like overall contour, right, closed surface basically. So here what we should do, we should put omega equals to 0, then put 1 point here, then put omega equals to like j1, then put 1 here, like not j1, omega equals to 1, and which is s equals to j1, then that point would have been mapped here, right, like this. So we would have mapped each of those points here, right, match each of these points between 0 to infinity here. Okay, so yeah, we have been doing mapping itself, not like totally that, because mapping is like mapping does varies the parameter from minus infinity to infinity, but here we are varying only from 0 to infinity. But we just unknowingly did that, right? We did the mapping, but we unknowingly did that. So mapping is nothing new concept. It is already, we have been already doing it, but the thing is we have now we will use the principle of mapping, which will help us to find the stability of control system, right? So this is, what is this basically? This is mapping of j omega basically. Okay, so this is mapping of j omega, right? So now let's do few examples. Let's map few contours, right? Let's map few contours, and from there your concepts will get crystal clear. So like pause the video and try it for yourself, then I will solve all this, right? So first one is like two poles are lying inside the contour, and I have like my contour is in the clockwise direction, and the second one is one pole is lying inside the contour, and this is in the anti-clockwise. Then what will happen to the direction, and how many contours will I get, how many contours will I get here? Okay, again, right, this is DC, CD, sorry, this will be D. Okay, so yeah, this is this one, and try to solve all this, right? So like I may have more questions also. Let me, if I have, here. So those were for the poles. Now for the zeros. Okay, like pause the video and try to do it for yourself. Pause this video here and here, right? So I have got three of this. You try to solve it by yourself, and then I I will solve it, right? So this is very easy. This will only take you like 5 minutes, I think, maximum 5 minutes, right? So yeah, I will come back after you solve it, right? Okay, so basically let's solve the questions. So here we have been given the first question, right? So what is the direction of the contour given here? The direction of contour is basically in the clockwise direction. That is the first thing that we notice. And like, what are the critical points that are located inside the contour, and what are the critical points that are located outside the contour, right? Inside the contour, what I can observe is I have two poles that are located inside the contour. Now what does that mean basically? So like, that will mean basically if I have two poles, right, and like I will get two encirclements about the origin. Okay, I've already written down. So the direction is in the clockwise direction, right, and I have two poles inside the contour, right? So like, due to these poles, obviously I will get like a contour which will have opposite direction, and what will happen is that that I will have two encirclements about the origin, right? So if I draw the axis here, okay, and that, what will the axis will be basically real of f of s and imaginary of f of s. Now of course I won't be able to exactly know how my contour will look like, but the features I am able to understand, right? What are the features? There will be two encirclements around the origin, and my direction of the contour will be in the anti-clockwise direction, because it is in the clockwise direction, right? My original contour was in the clockwise direction, so it will be in the anti-clockwise direction. Now how will I draw it? So basically, right, you can draw it something like this. Okay, so you can draw it something like this, right? And direction is, okay, let me color this properly. Direction is in the anti-clockwise direction basically. Okay, it is going like this, then it is going like this, right? Okay, so this is how, like I'm just assuming this is how my contour would look like, right? So obviously I will have like only one single point, but my contour will have two rotations around the this origin, right? Around this origin I will have two encirclements, right? So I will tell you the difference also between encirclements and other things, right? So yeah, I will have two rotations for the first question. So I hope you got the concept, right? So now let's go for the second question. So here, right, what first what you observe, what is the direction of my contour? The direction of the contour is in the anti-clockwise direction. So direction of my contour is anti-clockwise direction. And what is the basically number of poles that lie inside the contour? Only one pole lie inside the contour, right? So I will have only one encirclement around the origin. Okay, only one encirclement around the origin, and like the contour that I will get, right, the mapped contour will be basically in the clockwise direction this time, because the initial contour was in the anti-clockwise direction. Okay, so yeah, so it will look something like this. Let's say, like, I obviously I can't predict the exact shape, right, but this will be something like this in the clockwise direction. Okay, so yeah, this is my resultant contour, basically mapped contour, right? Okay, let me use another color here. Let's use this one. Okay, here also this is my mapped contour. Okay, now what about my 4C, third question? So here, right, what I observe is, like, this is in the clockwise direction, and I don't have anything. I don't have any pole or zero, nothing, right? So what, like, obviously it will not encircle the origin, but what it will do, the direction will also remain same, right? Direction won't change. Okay, nothing will happen, just it will be mapped simply like this. Okay, So this is like this. This is like this, right? And like direction will still be in the clockwise as this is in the clockwise, right? So this will also be in the clockwise direction. So this is very simple, right? Now let's go to the next question basically. So here, right, what we observe is like we have a contour in the clockwise direction. Okay, contour in the clockwise direction, and we have a pole on the contour itself. So this becomes very difficult for us to plot. So we'll see how to plot this basically. So first, right, what I will do is I will take the mapped function. Okay, and what does this point represent? This point represent that I'm at minus 3 comma 0, right? 3 comma 0. Okay, so what I will do, I'll put s equals to minus 3, but I will vary omega, right? Because omega is, I can see omega is varying just from negative to positive. So I will put omega as a variable to understand like how will my mapped function look like around this pole, right? Around this pole, because obviously the magnitude at, if I put s equals to minus 3, what happens? It goes to infinity, right? It goes to positive infinity. Magnitude goes to infinity. But what is the phase? We have to understand the phase also. So we'll try to understand this, right? So what I will do, I will write this, right? I will put s equals to minus 3 plus j omega. Now omega is varying from let's say positive negative or negative to positive here, right? In this case it is varying from negative to positive. Okay, so if I put s equals to this, right, in the f of s function, what does it become? So this becomes, right, so this becomes basically minus 2 plus j omega, and this becomes j omega, right? This becomes j omega. Okay, so now I can write the angle and the magnitude. So magnitude I can see if I put omega equals to 0 here, obviously it goes to what? It goes to infinity, right? It goes to infinity. Okay, so what else can I do? What else can I do now? So now I have to find the phase basically. For that, what I'll do is I will simply do cross multiplication of this one, right? Do the cross multiplication, right? Now this is minus 2 plus j omega into minus 2 minus j omega into j omega, right? And what is this? This, right? This is basically and numerator will be minus 2 minus j omega, right? Okay, so this becomes 4 plus omega square, right? 4 plus omega square. Okay, and here we still have j omega. Now what I will do, I will separate the real and imaginary components. That's how I will understand, right? That's how I will plot. Okay, so this becomes, okay, minus 2 by, okay, this j goes above, so this becomes plus j 2 by omega into 4 plus omega square, and this one, like this minus j omega is getting cancelled with this one, so this is basically minus of 1 divided by 4 plus omega square basically, right? 4 plus omega square. Now what you need to do is you put s equals to like so not s, omega equals something positive. Okay, something positive you put. What do you see? Something positive you put, your imaginary part is positive, right? So this is my imaginary part, right? This is my imaginary part and this is my real part. Now do keep this in mind, all these, right, are not that important for your exam point of view. For your exam point of view, what is important is coming into the next lectures, right? This is just the basic theory building block for who are interested in this, right? So like basic thing, what is important is for the exam point of view, that will understand in the next few lectures. This is just for a few people who are really curious about the mapping function, right? So now this is the real part. Okay, so imagine real part. So if I put something omega just positive, negative, right? If I put negative, what do you see? My imaginary component is negative. If I put omega something just positive, my imaginary component is positive. So it will be something like this, and my real component is almost near about minus 1.4. So if I plot this one, right, obviously I won't have other contour because the other contour is lying outside, right? So I won't put the other value. Okay, so here, right, what will happen, like this is the asymptote basically. Okay, if you just convert it into angle formula also, you'll see like it will almost vary from this plus 90 to minus 90 angle, right? And like the real component will lie on the minus 1/4. So we have done a question like this in polar plot, I think. So this will be minus 1/4. So it will look something like this. Okay, it will not basically pass the origin, I think. Okay, like, I'm not sure, but it will look something like this. I'm not plotting it in computer, and this is not that important also. Okay, so yeah, the shape will be something like this. So this is the question, and this is not that important if you couldn't understand it. So we'll go to the next few questions. So you just see the next few questions, and I will again, right, come back with the next few questions. Okay, so yeah. Okay, so basically let's start with the first question. So the first question, right, what will my mapped contour look like? So I have two zeros in the contour, like inside the contour I have two zeros. So what I will get, I will get two encirclements around the origin, right? I will get two encirclements around the origin. So I will have two encirclements around the origin, and the direction of the contour will be basically same as my original contour, right? Anti-clockwise. Hence my mapped contour will also have anti-clockwise direction. Okay, so this is like the real of f of s, and this is the imaginary of f of s, right? So basically, right, my contour will be something like this. Okay, two encirclements around the origin. Okay, and now this point, at this point may lie somewhere else also. I'm just drawing the rough diagram. Don't like get totally into it that like this point will lie here, or like the intersection, right? It may not so happen there. They may intersect at here. So for your convenience, right, what I will do is, like, I don't know the exact plot, right, and we don't even care about that. That is the beauty of this, right? That is the beauty of this. So this, what will the direction will be in the anti-clockwise, right? Anti-clockwise, right? We don't even care about this, right? What is the important thing that we care about is the encirclement, and why we'll understand in the next lecture basically. Okay, so this is just a bit of the theory building part. This is not that important, but even if you don't understand, right, not that like, it's okay, because the next lecture is the most important part where most of your gate questions will get solved, right? So this is again, right, mapped, right, mapped. Okay, mapped version, because I will get two encirclements because I have two zeros inside the contour basically. Now let's go to the second question. So second, I have two zeros, right, which is inside the contour. Again, right, I will get two encirclements around the origin. Okay, it doesn't matter if like it's inside these two zeros or these two zeros. Location of zeros don't matter, right? What matters is how many number of zeros or pole are inside the contour. Okay, and the direction of my contour. So again, I will get same, but like the behavior of contour will be a bit different, but overall important things will be same, right? What is the important things? The encirclement around origin will be same again, right? Okay, let me write this in different pen actually. What should I do? Okay, so, and again I should copy this one for the next one, because again I will have to make another one, right? So just copy this one for the next one. Just make this one a bit smaller. So basically, right, basically this one will also have like two contours around the origin, but this time, right, direction rotation is clockwise. So here, right, it has clockwise rotation, right? It is rotating in the clockwise direction. Okay, clockwise direction. So it will be something like this. Okay, okay, again, right, it may so happen that they are intersecting here, right? It may so happen there. Wait, just, okay, I'm just drawing a rough diagram. It may so happen the mapping may not look like this, but what are the important points? The encirclement and the origin and the direction of the contour. Those two are the important points. Here, right, the direction of the contour will be in the clockwise direction itself, right? Clockwise direction itself. Okay. As you can see, right, it is in the clockwise direction, right? And here, right, we have two encirclements around the origin. Okay, so let's go to the third question. So here, this is touching the zero, right? So what will happen? What happens when the contour touches the zero? My mapped contour also touches the zero there, right? Because that is what the basically function is. So what will happen? We'll get a contour like this, right? We'll get two contours. One will touch the zero and one will have encirclement around the origin, because 1 0 is still inside the contour, right? 1 0 is still inside the contour. So that is you have to keep in mind. So again, right, the direction rotation will be still same. It is clockwise direction, so this will be still in the clockwise direction. Okay, this will be still in the clockwise direction. Okay, so this is still in the clockwise direction, right? So yeah, this is how like the mapping will work. Now let's study about bit of the principle of argument basically. So what do you mean by principle of argument? So basically, right, here the definition, let's read the definition first. If there are p number of poles and z number of zeros that are enclosed by any randomly selected contour in S plane, then the corresponding plane will encircle the origin n times. Okay, basically n is equals to p minus z. And what is what is the direction of this n? Direction of this n is opposite to the direction is basically opposite to the given contour, right? Opposite of the given contour. Okay, so yeah, opposite of the given contour. So this is basically the direction of my contour, right? So like what do I mean by this? Until now, what we have been doing, we have been doing that only, right? So what we have been doing, we have been calculating how many number of poles or zeros are inside the contour, and that will give me the number of encirclements around the origin. So basically that is what this principal argument is telling, and nothing fancy, right? So n is the number of encirclements around the origin. This is the most important thing. Okay, just you have to remember this formula. Okay, so why we will understand. What p is the number of poles inside the contour, and there is the number of poles inside the contour, right? So this is inside okay. So this is what my p and z are, right? So like now what is the direction of basically now we'll understand according to the direction of flow of my previous contour, how will my new mapped contour direction will be. So here, right, if my direction of my previous contour or the given contour, right, is in clockwise direction, so if my p is greater than z, that is the number of poles inside the contour is more than the number of zeros inside the contour, then my direction of my new contour will be in the n will be positive, then the direction of the new contour will be in the anti-clockwise direction, right? Anti-clockwise direction. Okay, and if my p is less than z, p is less than z, then obviously n becomes negative, so it is in the overall in the clockwise direction, right? Overall in the clockwise direction, and like n is overall negative, so overall it is clockwise. And if my direction of my previous contour, basically the given contour, right, this contour, if it is in the anti-clockwise direction here, right, if it is in the anti-clockwise direction, then if p is greater than z, then n will be positive. Okay, p is greater than z, n will be positive, and if n is positive, then what does this mean? This means that my direction of my mapped contour will be in the clockwise direction, right? And if p is less than z, what does it mean? The n becomes negative. Here p is less than z, n becomes negative, so direction of a mapped contour becomes anti-clockwise, right? So this is opposite to the contour, this is with the contour. Okay, this is with the contour. Here this becomes in the what is it? Yeah, same direction of contour. When zeros is more, right, when number of zeros is always more, so zeros don't change the direction. That's why when number of zeros is more, right, then direction remains same. Okay, direction remains anti-clockwise here, and it remains clockwise here. When number of poles increases, so hence the direction also changes of my mapped contour. The direction also changes. So just we have to keep that in mind, right? So slowly as we solve the questions, then also we will understand. Okay, so I have like got more questions here. Now what will happen is we have both poles and zeros. So with the help of both poles and zeros, we will be able to clear out doubts. So don't worry if you couldn't understand there, we'll clear out doubts here. Okay, so let's go to the basically first plot. This one is the first, right? Yeah, where I have one pole inside the contour basically. So if I have one pole inside the contour, what does this mean? P n equals to p minus z. So p is 1 minus 0. So 1 minus 0 means one encirclement around the origin. N is the number of encirclements around the origin in the what? Opposite direction. Okay, if n comes out to negative, then the direction changes. Okay, so if this is in clockwise, so it will be anti-clockwise. So this is how you will solve, right? We will not be solving using the previous method. That was just for the example. Here now we will solve it with the actual procedure. So now what do you understand? N equals to p minus z, which is 1 minus 0. So 1 encirclement around the origin, and it is in the anti-clockwise direction, right? Because n is positive, so it will be opposite direction. Okay, if n is positive, it will be opposite direction of my original contour. So this will be basically something like this, and it will be in the opposite direction, right? In the anti-clockwise direction. This is A and this is B basically, right? So no, this is not B, this is basically the mapped function. This is like 6A, I think. Yeah, 6A. Now let's go to the 6B, right? 6B. Again this time, right, I have all three inside, right? All three inside. Okay, pole 0, so you just check, right? All three inside. Okay, if I have all three inside, now how many number of poles do I have? I have 2 number of poles and 1 0. So overall, what will be my encirclement? Overall my encirclement will be basically, right, overall my encirclement will be 1. Okay, where n equals to p minus z, so n equals to 2 minus 1, which is 1. Okay, and it is in the opposite direction of my previous contour. So I can write, I may have to copy this one. Okay, I did not. Just hold on a second. So this is basically real of f(s), this is imaginary of f(s), right? And if we copy this one, okay, and if we take this one here, paste this one for the other 4, right? This also is it recording? Yeah. Okay, so yeah, now for this, okay, we had another one also, I think. Yeah, we had the 0 also, so we'll copy, use another page. So basically let's do this 6B, right? 6B. So what will happen here what I told, right? So I will have one encirclement around the origin overall, because n equals to p minus z, so 2 minus 1 overall encirclement around the origin, and basically, right, it is in the anti-clockwise direction, because we have 2 poles, right? And poles like change the direction. So overall my poles is greater than the number of zeros, so obviously my direction will change this time, so it will be in the anti-clockwise direction. Okay, obviously I don't know the exact form of the contour, but this will be like this, right? That is a main important point. Okay, it will be in the anti-clockwise direction. Okay, so I will not draw it, because drawing it will be difficult. What I will write here is that my number of encirclements around origin will be equals to p minus z equals to 2 in the what, in anti-clockwise direction. Okay, sorry, this is p minus 2 minus 1, 2 minus 1, okay, which is equals to 1 itself. Okay, so what about this one? Obviously I will not draw the contour because drawing the contour will be difficult, but what information I can find out? The direction of the contour and the how many number of encirclements. This time, right, it has two poles inside the contour, so I will have two encirclements around the contour, right? Two encirclements around the contour. Okay, and okay, it will look something like this only, right? It will look something like this only. Okay, in the anti-clockwise direction. And whatever this here, right, I have two poles inside the contour, so what will happen? I will get like two encirclements around the origin, right? And what will be the direction will be opposite only, right? Opposite only, so it will be something like this. It is in the clockwise direction. Okay, so they will be in the anti-clockwise direction, both of them, right? Anti-clockwise direction. Okay, both of them will be in the anti-clockwise direction, right? So like here, right, I can write number of encirclements around the origin is 2. Okay, this one got copied. In the anti-clockwise direction, right? 2. Okay, so now like here also I have one 0 inside the contour, only 1 0 only, right? So here what I can say, I will have one one encirclement around the origin, but this time, right, my direction won't change. It will still remain in the clockwise direction. It will still remain in the clockwise direction, right? Okay, so again if I copy this one, sorry for the interruption, actually, like, yeah, your other mentor came to disturb me. So this is one only. Okay, so this is in the clockwise direction basically. Sorry, this is not 2 minus 1, this is basically 1 minus 0. Okay, so yeah, in the clockwise direction, and this will be in the same direction as 0, right? So now let's do a question. Okay, this is very interesting question. So just read the question. Like, we have been given a contour and we have been given that the mapped function, right, mapping function has the characteristics like this, right? If it has f s plus z1 into z s plus z2 into s plus z3 equals to this, right? p1 plus p2 into p3. Now what you have to tell is basically these options. Okay, you just read the statement and try to tell all this, right, whether each of the statements is correct or not. This is the MSQ question. You pause the video and you try to solve it, right? So what does the statement say? When the closed contour is mapped into FFS, so this closed contour is mapped into FFS. Okay, the points are given here, right? Points we can identify, right? The edge points, that is. Then the number of encirclements around the origin of the new mapped contour. Basically, it is asking about the n, right? Is 0. It is given that n is equals to 0. It is given that n is equals to 0. So if n is equals to 0, what does this mean? If, like, given n is equals to 0, n is equals to 0, so what is n equals to? N is equals to p minus z, which is equals to 0. So p equals to z. So what can happen? Like, either p can be non-zero or equals 0. So either p equals to z equals to 0, that can also happen, right? P equals to z equals to 0, that is one criteria. Or p equals to z is not equals to 0. These are the two cases that may happen right now. Okay, these are the two cases that may happen, right? Now what is, like, p is not the number of poles of this function, right? What was p? P was the number of poles inside this contour, So what are the statements saying? Let's read them first. So okay, I have to change this. All the poles, this is p, oh sorry, all the poles and zeros of f of s lie inside the contour. All the poles of f of s and like f of s all the poles and zeros of f of s lie inside the contour. Is that the case? If all the poles and zeros lie inside the contour f of s, what does that mean? If all these two poles lie inside the contour and all these three zeros lie also inside the contour, then what will my n become? N will become what? Number of poles minus number of zeros. So n will become here, right? My n will become basically number of poles minus number of zeros. So I have 2 poles and 3 zeros. So 2 minus 3, which is equals to minus 1. Okay. Now that is incorrect because my n is 0. N is 0. That we know. So this option A is not correct, right? Option A is not correct. Okay. That is gone. Now what about option B? There are 2 zeros and no poles inside the contour. It is saying there are 2 zeros and no poles inside the contour. So if there are 2 zeros inside the contour and no poles, right? Again, right? What does my n become? N again becomes 0 minus 2, which is equals to minus 2. Again, right? This is false again, right? This is false again because n is 0, right? N is 0. We know n is 0. Okay. Also, we know there are no encirclements around origin, right? And if there are 2 zeros inside the contour, then there will be 2 encirclements around the origin, which is again wrong. Now, it is saying all the zeros cannot lie inside the contour. All the zeros cannot lie inside the contour. So, is this true? All the zeros cannot lie inside the contour. This is true. Why? Because if all the zeros lie inside the contour, then I need 3 poles to like what? To negate that, right? To basically make it 0. Okay. To oppose the effect, right, of the zeros, I need 3 poles. But at max, I can have 2 poles. So if I get 3 poles, right, then 3 minus 3 becomes 0, and hence number of encirclements around origin becomes 0, which is given in the question. Okay. So all the zeros cannot lie inside the contour. This statement is true. Okay. This statement is true. Okay. So option C is true. Now this is where the MSQ come up, right? Basically analytical thinking. Here, right, you just use the formula, you got to the answer. But here you have to think out of the box also. Just by using the formula, you won't get to the answer. So gate exam is like that also. Sometimes you have to think out of the box and with your mind, right? So now, if all the poles lie inside the contour, then 1 0 must lie outside the contour. Okay. Now this is telling the opposite thing. Like if all the poles lie inside the contour, okay, all the poles lie inside the contour, right? Then I have 2 poles inside the contour. To make my n equals to 0, what does z needs to be? So it is given that p equals to, so here, right, also you can use the formula that if all zeros, like it is saying all zeros cannot lie inside the contour. So what you can do, you make z equals to 3. If z equals to 3, n at max can go to minus 1, right? At max can go to minus 1. So yeah, this is not possible, right? This is n should be equal to 0. Here, if all the poles lie inside the contour, so p is equals to 2, then 1 0 must lie outside the contour. So if p equals to, and n has to be equal to 0, so 0 equals to p minus z, which is equals to z equals to simply 2. So 2 zeros must lie inside the contour and 1 0 must lie outside the contour. That is what this statement is saying. So this statement is also correct, right? So this statement is also correct. So yeah, basically option C and D are correct, right? Option C and D are correct. So this is basically what the MSQ is. So yeah, this is basically it for this lecture, and I will see you in the next lecture, which is very important for gate point of view. This was just to build the basic building block of mapping theorem and Nyquist plot, and the next lecture is where the most important parts will come up, right? And from where we will solve the question. So this was basically the concept building part. So don't worry if you couldn't understand it. Slowly, when you will start to do questions, you will be able to solve all the questions just by watching the next lecture. Okay. So I will summarize all this, right, in the next lecture. So yeah, thank you for watching.